Hey, everybody. Welcome back. I'd like to talk with you a little bit about graphing. Our first lab has a graph that you're going to be asked to create in that. And so I'd like to make two videos, one kind of generally talking about graphing so that we're all on the same page, and the other one specific to Google Slides, Google Sheets, to explain what's going on. So let's talk graphing as a whole. My guess is that when you first learned how to graph things, people probably taught you how to graph, and you used a type of graph that looks like this, kind of in general. It might have had some of these tall shapes looking like this. We call this, a graph a bar graph, and they work great for a specific type of data. That type of data is called non-continuous data. So non-continuous data is data that you can't really imagine clearly something that would fit in between these bars. Let's say, for instance, you wanted to make a graph of different animals. Like down here, we said that this is a rabbit, and maybe this is a bear, and this is a whale. And we're talking about on here how much each one of these animals eats on a daily basis. Now, by no means do I think that this is a correct set of bars here, but this would be non-continuous data. Non-continuous in the sense that if I have a rabbit next to a bear down here, that's fine, but you can't easily imagine something that's like in between a rabbit and a bear. You might be able to. You might pull up something. You're like, well, I think this is in between a rabbit, but it's not. It's not a super easy task, right? But there are other kinds of data out there that are not non-continuous data. We would call them continuous data. And continuous data is not great for graphs like this because we can imagine something in between. And a graph that works out really well for continuous data is a graph that we could call either an XY scatter or a line graph, right? A line graph allows us to have all points being met, even if we just have some particular points that are being kind of graphed overall. And continuous data means that there's something that we can imagine easily in between there. And if we had kind of speed on the bottom of a graph like this, we could imagine a speed that would be in between these 2 points because that's an easy kind of continuous set of things. So we're going to go ahead and talk about continuous data, and that's mainly what we're going to be doing. In fact, we're almost never, if ever, going to be using bar graphs in this class, so get comfortable with that as it goes. Another time you were introduced to graphing is that you saw graphs that in algebra class had all 4 quadrants that we were looking at. So you ended up with quadrant number 1, quadrant number 2, 3, and 4. Right? However, in science, we don't always use all of these quadrants, and you've seen this already, where we're either just using quadrant 1 when we were thinking about graphs that dealt with kind of something versus time, or even that graph that was quadrants 1 and 4, where maybe position was on this axis and time on this axis. So these are important things to recognize, is that we don't always use all 4 quadrants, but they still exist. We just don't draw using them. So let me go ahead and give you here's a quadrant 1 graph that we're looking at. And if we're making a graph, there's some really important pieces that go into it. The first important piece to a graph here is we need a title. I usually put my titles up on the top. I think it's clear and easy to find. And so we definitely need a title. However, what should a title be? What would make a good title? I've been teaching this long enough that I've noticed that some of my students like to title their graph Graph. This, I'm afraid, is what I would consider a very bad title. It doesn't tell you anything about what's going on. Yes, it's a graph, but what's going on inside of it? It's like naming a book. And no offense, but that's not a great title for a book. So in this case, you might want to title the graph something like Clip D Motion. Or even better than that might be Clip D Car Motion. So we've got some idea of what's going on inside of that. So I have a nice clear title in the end. Down below, I'm going to go ahead and label some of these here because we need an axis label here and we need an axis label over here. So I'm going to go and drop in my first axis label right there, and I'm going to go ahead and call this time. That makes for a good, nice title there, but I also need to put something next to time. So I have the label, but I also need to include my units. And my units for time that we are using here are seconds. I'm going to put that in parentheses, making sure that I've got it. If I come over here to this size, I'm going to go ahead and draw in another label. So maybe I would call this position. And that position in this situation could be in centimeters, which is a good way to get things going. So now I have a label and a unit, a label, a unit, and I've got a title up here at the top. Am I done? Not exactly. I do need to have numbers that help me to understand. And the most important rule of the numbers is that graphs need to have what are called even interval axes. An even interval axis means that the numbers that kind of fit along this axis here need to be spaced out nicely so that the same amount is between each of these numbers. I'm going to move this time down here a little bit. So I can't put numbers like this, where this number is 5, this one is 15, and then I've got maybe 16, and then 24, and then 100. These are not good numbers because our numbers are separated by different amounts for each one. So 5 to 15 is a separation of 10, and then 15 to 16 is a separation of 1, and 16 to 24. You get the picture. They're not even interval. So whenever we do numbers on a graph down here, it's critical that our numbers are even interval. So that could be 1, 2, and 3, or it might be even interval in the sense that you're talking about maybe this is 5, 10, 15, but nonetheless, they're the same amount that it goes up by the whole way. We can't suddenly then jump in here and put 40 because that doesn't allow the user to understand, or the reader to understand what's going on. So an even interval is critical. When we're talking about time in this graph, we're actually going to use fractional amounts of time. And so with our kind of YouTube video, every frame is being shown for 1/30th of a second. How do I know that? Because YouTube plays out at 30 frames per second. So if it's 30 frames per second, then every frame themselves only gets shown to the screen for 1/30th of a second. And I could write that in here and I could say, here's 1/30th. And then the next one would be another 30th more. So there's 2/30ths. And then maybe 3/30ths, but it gets kind of crowded down here. I could do it in decimal, but still crowded. So I could, if I wanted to, not write every single line, but I could write in some of the lines, and that could help me out. So maybe this is 1/30th, 2/30th, 3, 4, and here's 5. So here's 5/30ths. Now I could reduce that, but I could also leave it just like that. It'd be fine because I'm really talking about each one as a 30th. So here's 5, 6, 7, 8, 9, 10. Here's 10/30ths. And yes, I know you could reduce it, but still, nonetheless, this allows me to go ahead and say, hey, I know what these are in between. Positions, on the other hand, you might want to think about this. If you're doing this, most of the time you've thought about that this is the origin and this is 0, 0. But in science and physics classes, we don't actually have this be 0, 0. This position right here could actually be 0 in time, but it could be some other quantity in position. I could start out here and say, hey, this is starting out at 28 centimeters right there. And then this one maybe is 29 centimeters, and this is 30 centimeters, and so on. It is okay to start without it being kind of at 0, 0. And that's important because we don't want to really kind of use blank space on our graph. So we're going to start it in a place that seems reasonable for us. And this will show up again when I do it through the Google Sheets that we're going to be looking at. So here's the big deals. Title that is understandable and not the title graph. Labels with units in parentheses. Even interval axes, and this origin does not have to be 0, 0. I hope that makes sense, and we'll see you again in the next video to try and make sense of how we can kind of graph these things that we maybe graph normally with kind of XY coordinates here, and we can use, instead of doing it by hand, which is semi-inaccurate and hard, to do it in a much easier way using a program like Google Sheets to do it for us. So we're going to not do a lot of kind of by hand graphing This year, most likely, we'll do most of our stuff using some digital tools like Google Sheets. So anyway, we'll see you in the next one, and I'll talk to you then. All right, bye.